Hello everyone, welcome to SAT Math. This is chapter 3, part 9, System of Linear Equations. So what is the system of linear equations? We have discussed the linear equation, but in the system of linear equation means here we will be having two equations in both the variable x and y. Just like, for example, if you see 2x plus 3y is equal to 7. This is only a single linear equation in two variable. But if I write one more equation with this, so this becomes this collectively this is known as a system of linear equations. The graph of the linear equation you know. So here we have to learn how to solve this. So in general we will be writing like this: a1x plus b1y equals to c1 and a2x plus b2y equals to c2. Now solution of this system of equation means the values of those x and y which satisfy both the equations simultaneously. Whatever is the value of x and y satisfying the first equation, similarly that should satisfy the second equation also. Just like one more example, I am taking a very basic one in which we can directly predict. Let's say x plus y is equal to 7 and x minus y is equal to 1. So in this system, I have created the system like this. You can see if you take x as 4 and y as 3. So look at this. 4 plus 3 is 7 and 4 minus 3 is 1. So this value of x and y is satisfying both the system, both the equations. So that is why this is called the solution of the system of equation. So we have to learn how to solve this. So now when we are talking about the solution, there can be different types of solution. Basically three types of solutions are there, in which we say no solution, one solution, or infinite number of solutions. And this is a very important topic in the SAT. Many questions are asked or based upon this topic. So first of all, we can divide the system into two ways. One is called consistent and inconsistent. Consistent system of equation and inconsistent. Consistent means at least one solution should be there. At least one solution. Inconsistent means no solution. There is no solution for the system of equation means there is no value of x and y which satisfy both the equations simultaneously. So in the at least one solution we have two category: unique solution and infinite solution. And here inconsistent we have only no solution. So this is the diagram you can see over here. This is known as the consistent and independent. This is also known as the independent. These are the intersecting lines which have exactly one solution. So this point of intersection over here, whatever is the coordinate of this point, that is the solution for this system of equation. That is called a unique solution, means it is intersecting on only one point. Second thing, when we say infinite solution, these are the coinciding lines. Both the lines are overlapping each other. These two lines are overlapping each other. So there are infinite points which are common in both of them. So that is why this is known as the infinite solution. But in the third one, no solution, you can see both the lines are parallel. If both the lines are parallel, they are not intersecting each other. You can see slope will be same, but their y-intercept is different. So this is called inconsistent and no solution. No solution also means parallel line. So in the unique solution, we will say intersecting lines. In the infinite solution, we will say coinciding lines. And in the no solution we will say parallel lines. So these are the three cases. So we have to see which one will be applicable in a particular system. So first of all, let's learn how to solve. There are basically two methods which we are going to use. First one is known as the method of elimination. So method of elimination simply says, let's start with this. Let's take one example. Suppose if I say 5x plus 2y equals to 7 and 3x minus 4y equals to negative 1. Now method of elimination I have to use to solve this. Although you can solve this directly on the Desmos, you can plot this on the Desmos directly, and second one you can plot it whatever is the point of intersection, that is the solution for this. Whatever is the point you are getting, that is the solution. But algebraically you should also know how to solve. Elimination method simply says that we have to eliminate any one of the variables. So you have to decide first which one you want to eliminate. Let's say I want to eliminate the y. In order to eliminate the y, I have to make sure that the coefficient has to be same. Right now the coefficient of y is 2 and here the coefficient of y is -4. So to make them same, I can multiply the first equation by 2 and second equation by 1. So multiplying the first equation completely by 2, so that will become 10x plus 4y equals to 14, and multiplying the second equation by 1, so that will remain same. Multiplying by 1 means same thing. 3x minus 4y equals to negative 1. Now you can clearly see that the sign are different. So if you simply add both of them, they will get cancelled, and 10x plus 3x is 13x. On the right hand side, 14 and negative 1 on adding, this will become 13. Dividing by 13 on both the sides, so x equals to 1. So now you can put this value of x, put in equation number 1. So this is the first equation. You can put in anywhere, either in the first one or in the second one. So if I put it in the first equation, so 5 times 1 plus 2y equal to 7. So 2y equals to 7 minus 5 is going to be 2. So y is equal to 1 for this. So therefore you can say this system of equation has a solution 1 comma 1. It satisfies both the equation. So the point of intersection of both of them, when you plot it on the Desmos, you will see that both the lines are intersecting at one point, which is the coordinate is 1 comma 1. This is called elimination method. Similarly, second method is called substitution. Let's solve the same method with the same question with the substitution. 5x plus 2y equal to 7. And 3x minus 4y equal to negative 1. In the method of substitution, what we have to do, from any one of the equation, you have to find the value of one of the variable, just like in the chapter number 1 we have done, finding solving for any one variable. So let's say from the equation 1, I am finding the value of the x. You can do it from the equation 2 also, you can find the value of y also, or value of the x also, doesn't matter. So I'm from the equation 1, I am finding the value of x. So 5x will be equal to 7 minus 2y. So x equals to 7 minus 2y upon 5. This is the value of x. Now substitute this in equation number 2. So in the equation number 2, if you are going to substitute, in place of x, complete this thing. So what we have done over here now, we have replaced the x, and now this complete equation is in terms of y. So let's solve this. So before solving, what you can do, one thing, this is the fraction, so remove this fraction, multiply complete equation by 5. If I multiply complete equation by 5, this will get cancelled. 5 times 4 is 20y, that is negative 5. Now distributing, 7 times 3 is 21, minus 6y, and this is minus 20. Minus 20y equals to negative 5. 21 minus 26y equals to negative 5. Negative 26y equals to, take this 21 on the right hand side, so negative 5, negative 21, negative 26. So dividing by negative 26 on both the sides, so y equals to 1. So if y equals to 1, again you can put in any equation. Let's say I am putting in the first equation. So 5 times x plus 2 times of 1 is equal to 7. 5x plus 2 equal to 7. So 5x equal to 5. So we can say x equal to 1 again. So this is known as the substitution method, finding the value of one variable, putting it into the another equation. But again, using Desmos, this is very easy. You just have to plot both the lines on the Desmos, and just like the point of intersection will be definitely 1 comma 1. So that will be your answer. Now, what types of equation will have no solution and infinitely many solutions? So in the no solution, what will happen? We have the parallel lines, and we already know in the parallel lines what we have, slope is same but the y-intercept is different. So whenever you have to check whether the system has no solution or not, just convert them, or if you want to find, we have to check they should have the same slope and different y-intercept. For the infinity many solution, the lines has to be exactly same, equivalent to each other. So in that case, they should have the same slope as well as the same y-intercept. So if the slope is same and the y-intercept is also same, that is the infinite solution. Slope is same but y-intercept is different, that is the parallel lines, so no solution. So we just need to convert the equation into the slope-intercept form and compare the slopes and the y-intercept. That is the way we are going to check whether it is a no solution or an infinite solution. Let's have a look on this. It is done. For what value of c will the system of equation below have a no solution? So in the no solution, I will be converting into the slope-intercept form. So in the first equation, I can say minus 2y is equal to 6 minus cx, y equals to dividing by negative 2. So minus cx upon minus 2 and plus 6 upon negative 2. So y equals to c by 2x and plus of minus 3. This is the equation number 1. Equation number 2, I will say 4y equals to negative 3x plus 4. Y equals to negative 3 by 4x plus 1. 4 divided by 4 is 1. Now for the no solution, the slope has to be same and y-intercept has to be different. So directly you can see y-intercept are automatically different, but the slope has to be same. So c upon 2, that should be equal to negative 3 by 4. So c is equal to negative 3 over 2. That is the value of c. Simple. Convert into the slope-intercept form. It is written, for what value of b will the system of equation have infinitely many solution? Now for the infinitely many solution, again if you convert into the slope-intercept form, the first one y will be equal to 2x plus 4. Now try to do it in the single step only. So we will be taking minus 2x on the right hand side, and second equation we can say minus by is equal to negative 5x and negative 10. Now dividing by minus b. If you divide by minus b, it is simply 5 by bx plus 10 over b. Like this it will work. Now if it is working in this way, so we can say infinitely many solutions, slope has to be same. So slope has to be same means 2 should be equal to 5 over b, and y-intercept has to be same. 4 is equal to 10 over b. So from here we are getting b is equal to 5 by 2, and from here also we will be getting b is equal to 5 by 2. Suppose if you are getting different b from both the cases, so you will say it is not possible to have infinitely many solutions. Now it is done. Solve the linear system. So you can solve by any method. Let's say I am using the substitution method. So this is the first equation, this is the second equation. In the second equation already the value of y is given. So just substitute this value y in the equation number 1. So just putting the value y as 2 by 3x plus 2 in the equation number 1 and solve it. So if you distribute this 3, so it is minus 2x and this is minus 6 equals to 5. So now you can see 2x will get cancelled. So value of the variable is eliminated over here, and now we are getting minus 6 equal to 5. So minus 6 equal to 5 is not possible. If it is not possible, so we will say simply no solution. This system will have no solution. So sometimes they can ask you to solve this and you are getting, suppose if the values of the variables gets eliminated and whatever is left, if this is mathematically true, then it is infinitely many solution, but if it is mathematically not true, then it is no solution, just like we have done in the linear equations in one variable. So I hope you have understood all the concepts related to this. Thank you for watching this.